right, welcome back. I hope you have taken time to actually do the activity as I had suggested in the first video. Now let's fill up our triangles here. I'm not going to do everything, but just to for you to check whether you're on the right track. If we take the adjacent in, let me just randomly pick triangle ADE here. If we take the adjacent is AE. So AE is an 8. And the hypotenuse in triangle AD is AD, which is 8.94. And I will take here the last one, the triangle ABC, the opposite is a 6. And the hypotenuse is AC, this one here. And that happens to be a 13.42. So that's what I've got here. And I want you to now have a look at what's going to happen when I introduce the following trig ratios. So there are 3 main trig ratios that we're going to learn before we get into other, that is the reciprocals and etc. etc. I just want us to focus on the basic. The first one is the sign. So this, I want you to note that is the full name, the sign. The second is the cosine, and the third is the tangent. As I said, these are not the only ratios. There are others, but for introductory purposes, we will use this. So the shorthand for that is, excuse me, sin, and the shorthand for this is cos. The shorthand for this is tan. As you can see, they all appear in your calculator. There it is, there's sine, there's cos, that is tan. So those buttons are going to be quite important as far as trigonometry is concerned. Another little thing that I need you to take note is we measured our angle in degrees. This symbol here, that's the degree symbol. And so we expect to have a small letter D. Well, it's capital letter D there on the calculator. We expect to have that. So make sure your calculator is in degree mode. Those are very important basic things as far as trig is concerned. Now, I want you to observe, this is your next task, which again, I will guide you into. I want you to observe that the moment you press sine 26.57, you're going to get an interesting answer. And that is not an accident. So I'm going to press that in my calculator. There it is. I want to go sine, and I'm going to go 26.57 like that. What do we get? I get 0. I will round this to 2 decimal places. So let's have this as 0.45. That's what I get. Now, I will pick up this ratio here in green, here in my triangle. And again, I'm going to type it in my calculator and just find out what it is in terms of decimals. So 13.42 is what we had measured, and it is something like that. And bingo, we get exactly what we had there for the sine of 26.57 degrees. So this is what we get. Again, 0.45. Obviously, I'm sure now you see where we're going with this. If you have already discovered these ratios at school or somewhere. Again, if I do cosine, I want you to see what happens then. If I go cosine 26.57, we get a value of 0.89. Now, let us take this ratio here and see what it gives us. So that is the adjacent over the hypotenuse, by the way. So I'm going to do that. Let's go. 8 divided by 8.94. And there we go. Again, in the money there, it corresponds with the cosine of 26.57. I guess you know now what to expect when it comes to the tangent. If I go tan 26.57 degrees, I can expect to get this. I will do it, and I'll take that risk. It's a half, which is 0.5, and clearly it is what I've got here. So you can verify that for yourself. on the calculator. So what have we discovered here? We've discovered a very interesting thing, that the sine of any angle, as far as right angles are concerned, will be the opposite sine over the hypotenuse side. We also established that the cosine of any angle in a right angle triangle will be the adjacent over the hypotenuse. Finally, the tangent will be the opposite over the adjacent. These are the three important major discoveries, fundamental, as I mentioned earlier, very fundamental, that you need to have a thorough understanding of as far as trigonometry is concerned. I'm going to go on and show you how these are actually important in problem solving. Okay, we're going to do some examples, and of course, I'll try and keep this video short so that they're not prolonged. So you catch that in the next video on how we use this as far as problem solving is concerned. Right.